is here.
Steve.
Dave, what's happening?
Up? Well, not too much. Let me fix your screen so you're back. I think your high desert Wi-Fi is still going to be acting up, but we'll see how it goes tonight. So what's up, man? How's your week been going? What's happening?
It's been going good, man.
All right.
I brought there's a lot of stuff going on. It's all good though. How about you? How you feeling today?
Good, man. Just long day, kind of long week, long weekend, but it's good. I can't complain.
Nice.
All right,
How's everybody
guys.
else doing?
Yeah, what's up, guys? We got got a lot of regulars up in the house here. So what's up, guys? Good to see ya. Gravity Gear. What's up, Gravity Gear? Drew Eddy, Jesse Velasquez, Winging It Tracy, Zoom at 75, who gives me tons of crap anytime he can. C72C, he's been giving me tons of crap. I'm still using the frame on Goldie, so don't you what is that?
This is rod.
Is that one of
those
those
pistons?
Oh
yeah,
stick-on deals?
Drew's talking about my white arm, so I'm gonna cut the sleeves off of this bad boy now.
Yeah. Got Ben up in here. Who else we
geez.
got up in here?
We got Tracy here. We got
Off-Road
some
Farm.
weirdo named Zoomad, and then C72C. Man, it really looks like a pedophile in his picture. Anyway, so
He looks weird as shit. I don't know what he's doing, but
he's like a midget or he's snorting something.
how do you say he was eating something?
I'm not sure. Yeah, right? I should cut the sleeves, Ben. That's the only chance we get to see Goldie. That's the only reason anybody shows up.
That's right here. She is tucked in the garage nicely. One day I'm going to work on this truck again. That's all. I just got a lot of stuff going on here.
In 3 years.
Huh?
Hey, it's a $25 shirt, Jesse. Oh, jeez.
I know you pay $25 for the site, then you got to pay $50 for a shirt. What's up with that?
No, I think it's on year 4 you get a free shirt or something. I can't remember.
Oh.
But
$100
wait,
in.
look though. No, it's cool, dude. Check it out. Can you see the back? You see it okay?
Yeah, kind of. Nobody wants to see that, Steve.
No, I'm just saying if you can see my back, dude.
Put it down. Anyways, guys, how we coming through? Is Steve sounding okay? Am I sounding okay? Everything looking good for you guys? Hopefully Steve's internet doesn't cut out. It's usually cutting out right about now, but we hope that it won't. So let's see what we got going on here. Zoom ad, he's always talking trash. But did you wanted to talk? You wanted to talk about some stuff tonight, didn't you?
I mean, so actually, we wanted to address rumors of Dave selling his truck. So, Dave, are you going to sell Goldie or what?
No.
About the K10?
No.
All right, you guys can all shut up and quit asking me.
Yeah, the Crawler Holler, you guys could come and bring a trailer inside the title.
Right?
Yeah, get that out of the side of my house. But anyways, no. Nothing's going nowhere. I'm just in a temporary holding pattern because it's wheeling season. And I got two little kids, and they drain all my energy, and then I don't have a lot of energy to work on trucks.
Drew is a bad influence. That's what Drew is. I don't got no money, dude.
What's Drew saying up in here?
He's talking about me buying the K10. I got enough projects at this point.
Yeah.
Hey, and you guys don't even know, but that LS right there, this amazing 300,000 mile LQ4, bad Mama Jamma, actually runs really good for 300,000 miles. No blow by or any of that stuff. Because it's all what?
I was telling Chris to pipe it down.
Yeah, Chris, shut up. But anyways, that's going into my brother's 72K10. Right now, it's on half-ton axles, about a 6-inch lift on 35s, Mickey Thompson wheels, and the small block locked up. So we might be a timing chain. What's up, Luis? Yeah. Oh, Chris is right on point. Anyways, So no boost, but it's gonna get a Tilden Motorsports makes this thing called a Ultra 4 cam. That's pretty sick.
I'm just showing. He asked what's going on with the engine. I tore it down on the video and never done anything with it other than that. That's it.
You're gonna get to where you put it back together
one day,
and get where you put the parts. You should throw the nuts and bolts in there and just put the heads back on. Just fill it up. Just take all like the old rod bolts and just throw it in there. Yeah, just put the oil pan on. Just like, hey, 5-3.
I know that it's good and it doesn't really need anything. I'll probably take it down, have some new cam bearings put in it,
Yeah.
and just have them
Doing
check it. But it doesn't need anything, so now I just got to figure out what I'm going to put it in. And so CJ Leon, Dave, what's going on? The next update video on Goldie? I don't know. I don't know when that's going to be. I hope in the next couple weeks I might get back on it. I got to a point to where I don't know. I don't know. I need to finish the brake lines and do some other stuff. So I don't know. We'll see.
We've been hearing the same thing for like 6 months. Anyway, so
oh, it hasn't been that long.
Yeah. So
Has it been
Ben's
that long?
asked Ultra 4 cam is. So I don't remember what the specs are, but it's a like they have a stage 1, 2, and 3, I guess, of that camshaft. But their thing is it makes power from idle to like 5,800, and it's like 70 to like 100 horsepower depending on your mods and stuff that you could pick up with it. So this thing has a lot of miles on it, and I just want to go through and pull it all apart, and then I'll take the block and get the cam bearings installed, and then I'll have it checked to make sure there's no cracks or anything. I don't really think there's going to be, just because of the fact that it made a really good oil pressure and all that stuff. So I got a buddy of mine that does machine work, and I was told it's not an RV cam. I actually was told that they have used the camshaft in their Ultra 4 race car for like 4 or 5 years, and it's really good for valve train and stuff like that. Yeah, right. Marky Mark is in the house.
Yeah. What's up, Mark?
Make me go look up the data here with the.
It's not an ARB. It's a 3/4. What you going with the 3/4 in this engine, Steve?
Oh, you mean race cam?
Yeah, 3/4 race cam.
Yeah. I was thinking about an 11/16 race cam. You know, Mark over here, he knows
15/16.
A 15/16 race cam, right? Yeah. 24 or 23/64 race cam.
Yeah, right.
Oh my gosh. But yeah, so that's what we're gonna do, and basically this thing is supposed to idle pretty smooth. Not be too crazy, because he doesn't want to have it be temperamental, and it's going to be like overlanded. It's going to have a camper, or not a camper, but a whatchamacallit on the back, one of those tents that you can take and flip out. It'll have one of those that goes on and off, because they go all over the country and they camp. So he'll drive it through northern Arizona and pull off of a trail and camp with the thing. And it's a long bed, so we're gonna probably end up doing some sort of a link suspension in the front and some springs in the back, maybe links. I don't know. We'll see what the budget looks like. The O2 that I pulled this from has a AAM 14 bolt basically in the back with the disc brakes, so we're using that. Putting either 456 or 488 in it. I'm not really sure yet, because it's got a 4L80 here, so I'm going to go through that also, and try and just kind of see if it's in good shape or not. It shifted really nice. It quite literally looks like it's never been apart. The transfer case, the rear half, has been replaced, so it makes me think it got that pump rub thing that they do. So they replaced.
How's the fluid look?
I don't know. I haven't drained any of it yet.
Let's look at that
out of
fluid.
any of them. Oil and anything I pulled it out with all the fluids in it, and I actually somehow didn't spill a bunch of stuff everywhere. So Drew is right, yeah, and that's the thing too, is he's not a go fast guy really. He's just going to cruise around. So I actually feel like the mileage is a myth.
Mileage is a myth.
No, you're right. You're right. Well, the LS doesn't have as much of a problem when it's spinning 300 more RPM than a small. I mean, they both don't, but I mean, it's going to get what it's going to get.
Right.
Like I thought mine was going to get worse than it got, and it does pretty good. About 15 to 17 on a good day, and then on 85 it's like 13. So
I want to give a shout out to my boy King Green. What is up, brother? It is good to have you up in here. I hope that you're out of the hospital and doing well. And
see, it's Chelsea's. Right. What's up, King?
And then also Winging It Tracy. Are you talking about the Universal Cam here, or Universal Machine Shop here in Vegas? And if so, have you had pretty good luck with them?
So, Tracy's talking about the 14 bolt. The e-brake stuff it's a factory emergency brake setup. So it's pretty dang slick. It gets inside the rotor hat, and there's a backing plate. So I'm actually on a mission too, guys. Oh dang! Bill Arrow's in the house, dude.
Oh shit!
The whole world is just going to come to an end. Man, it just changed the whole world right now. Anyway, so I'm on a mission to figure out how you can take all the AAM stuff and put it on an old school 14 bolt. Because I actually found a place that has all the parts, the backing plate, the all the little pieces that hold it together. There's a little bracket that goes onto it. So yeah, I'll have to check it out once I get it all apart. I'm going to measure the one on my pickup versus this one when I get it out of the truck. But anyways, enough of me droning on about LS swap. You guys want to hear about that? You guys came in for. I got something for Dave, and it's chrome, and it's a shaft.
Oh, I love that. A C72C, he loves that too.
So I'm not going to do anything inappropriate because we're going to try
Well,
and put
I
this.
think your internet's gonna go. I think it's gonna go. I hope not.
It looks like it's slowing down.
Oh yeah, you got smaller, but I'll fix you up. Okay, keep doing what you're doing with that shaft
So
there.
this is
Pretend like
this
nobody's
is
here.
FOA shaft. Okay. One of the tell it's FOA is the massive O-ring grooves, and there's two of them, which is not normal. If you look at a normal seal head, which is what this is, and it actually goes down on a normal, coilover shock. The seal, there's usually only one O-ring, and it's literally like half the size. One of the things that I found out when I took these apart was, and some of you guys have seen this, but it's a huge clearances, man, and they're using double O-rings to take up the difference, which really creates a bunch of what I call static friction. So like the fact that this thing doesn't like go all the way down by itself is pretty frustrating from a. I mean, there is just there. I mean, there's a decent amount of friction here. So I wanted to talk to you guys about shocks because there's a lot of stuff that has impact on how your truck rides. Yeah, Dave's playing with it because I'm all.
I'm trying to give you your own screen, but
yeah. Anyways,
whatever.
So Chris has been through this.
Playing with your shaft.
Revalving a shock is a pretty simple process. But what I wanted to talk to you guys about was what happens right when you hit a bump, and a lot of people haven't seen the inside of a shock. So, like, it's really super simple. There's these things are stacked up, okay, and they go on the shaft, and there's a nut on the top, right? And there's these holes that you got on the top and the bottom. The top holes are the rebound. The bottom holes are the compression, because when the shock moves up, these discs deflect, and then when it comes back down, these discs deflect the other direction. And the reason it creates damping is because when you have the holes here, it's sealing off portions of a port, right? So it's very interesting when the fluid comes up through the bottom. I don't know if you guys can see that or not. You see how there's when I put this disc over there, it covers that port up? Can you see that okay, Dave? Is that coming through?
I made you big, so you're on the whole screen now.
Okay. So when the fluid comes up through this hole, and on a compression side, the amount of holes that you have available to you is greater, because and it may not necessarily be that way on this, because this might be a equal flow on compression or rebound. I don't know if it is or not. So that's the compression side. You see how there's basically 6 openings, right? And then on the rebound side, you only get 3. That's because the rebound does not flow as much as your compression side, because you don't need near as much damping available to you on the rebound. It's just you just don't need it. Now there are some pistons that flow equally both directions. So like a Bilstein 7100 or an 8125 has a piston that you can flip over and it doesn't matter. Any of the old 9100s, a lot of the standard pistons are the same on both sides. They don't look anything like this. It's a totally different design. If you buy a 9200 or you get a linear piston in a Bilstein, or like a King or a Fox, they're going to have a higher flow piston like this. Now, one of the things I'd like to point out real fast is the machine quality of this is a joke. This is a cast piston, and then they do some rough machining. But I mean, this isn't the cheapest shock that I've ever encountered. And I mean, it's just terrible. I would never buy an FOA shock. This is the reason why. I mean, look at this spacer. I'm not just saying that, guys. Just keep in mind when you buy a shock, um, it's got to work, and these are little things that all add up to it not working quite exactly right. It would be like if you took an engine that you got from the junkyard and put an undersized bearing in the crank or something, and you had all this friction that was unnecessary. Well, it takes power, it creates heat, all these things add up, and it just is not moving freely like it should. So, that being said, it can still work. Is it optimal? No. Are you going to feel it? Yes, probably. Another point of contention that I have here, if you look at the shims, you can kind of tell that they're cut from a sheet. I don't know if that's coming through or not, but basically,
Everybody can see. We're good.
Okay, cool. So Drew made a good point, and I already thought about this, so I brought a caliper because I'm a geek. Okay, so we want to know what tolerance stack up we have here, right? So I'm doing it in thousandths of an inch. So, like, for example, the bore here for this DU bearing is 0.8785, right? The shaft is 0.8700. It doesn't sound like that much. What was that 8785? So it's 800. Was that 800ths or 8,000ths? But you could feel that. I mean, listen.
Oh yeah, feel it, buddy. Yeah, you can feel that.
Can you hear it? You can hear it knocking, right? So that bearing is really long. It goes all the way to here. I don't know if you can see that or not, but that's a long bearing. That should not. That bearing's whole job is to keep the shaft from rotating inside of this. You don't want to have any deflection. So when this thing gets loaded sideways, if it can deflect, you're having a. Yeah, right, Mark. I got to represent, right? When this shaft is moving upwards, it's not always going completely, perfectly straight into this bore. There would be a shock body here. The piston would be on the top. This thing's doing its job, so it's getting force here and it's getting force here. So you're going to have some deflection potentially, depending on how this is mounted. That will affect it, but it's definitely a problem. And heck, you know what else is kind of interesting? I just realized. I think this thing. Oh my gosh, yeah, like it has to be 2 or 3 thousandths of just little. I can just push this thing, and it just rocks side to side. So I'm this bothers me a lot, and it's probably more than it should bother me, but it really pisses me off when you buy something from a company and you're expecting something and you just get completely the opposite. Test 1 2 3. Okay, sorry about that. Dave is clicking buttons. Freaking Dave. Oh, okay. Okay, so test 1 2 3. So basically, almost all off-road shocks are monotube. What that means is the oil and the nitrogen are separated with a piston of some sort. It's a dividing piston, right? Actually, I'm gonna. No, you're not muted. Hold on a second. I'm gonna grab a shock. Give me 2 seconds.
Test, 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 test. Oh, you guys can hear me now. I'm back. Too bad for you.
Why, thanks, Bill. All right, so I grabbed the next best thing. This is a bump stop. So this is off of Rafo's race truck. So a bump stop, quite interestingly, is this is an emulsion shock, which means that the oil and the nitrogen charge are together in the same chamber, and there's no way of separating the two. So that means when this thing cycles extremely quickly, if these aren't charged to 200 psi or 300, I think the max is 300. It wants to cavitate, which is ironic to me because the entire job of a bump stop
How's
is
that?
to.
Is that better? They're saying no sound, but is anybody not getting sound right now? Everybody should be getting sound.
I'm gonna wait until they respond because I don't want to mess with people. If we got to come back, we can. Okay. All right. Cool. Thanks, guys. Sorry for the pause there.
Yeah, technical difficulties here. I need a producer. So anybody want a producer job, I can't pay you, but you can come and hang out and maybe work on Goldie a little bit and
Yeah.
produce the show. Yeah.
So, what I was getting to point at here was an emulsion shock will foam up, right? So the problem is on a monotube shock, if you don't separate the oil and the nitrogen, it'll foam up and the dampening goes away completely for a split second. That's bad. It's like probably one of the worst things too, because when the cavitation bubble catches up, now you went from no dampening to all of it, and that causes a spike, and you feel a spike, and that's not good. So Bill Stein in the 50s with Mercedes invented the first monotube shock. After that happened, that just basically became a standard because it was higher performance.
Yeah.
You could what?
No, I'm not to you. These guys talking
Okay.
trash down here.
Oh, okay. So the key here is that you get to benefit from trickle down because that came from race cars and whatnot. So King, Fox, ADS, FOG, Pro Fender. Trying to think of who else. There's a whole bunch of companies out there that make monotube off-road racing shocks.
There it is. There it is. Desert Wi-Fi just went out. It's high desert frickin' internet. Let's see if we can get him back. Hold on. You know, guys. All right, hold on. Let's see what we can do here. I love the abuse, guys. So keep it coming. Let's see if we can get old Steve-O back here. You guys probably lost me too, but I'll keep talking to you if you can still hear me. Hold on. Let's see. Steve.
Hey.
Okay, so while you're gone, there was some talk about you being an IT guy, and you don't. I mean, what's going on over there?
Are we live right now?
Yeah, we're still live.
Oh, we are?
Yes,
I
it,
thought I thought we were here to talk about trucks.
we are. I think.
Are we? I mean, just because I'm an IT guy doesn't mean I'm an internet guy.
Oh, is that right?
Yeah, it has nothing to do with that. That'd be like saying I work on trucks and I know things about RVs. I don't. I really don't.
Copy that. They're just big trucks.
I mean, I guess so with refrigerators and shitters. So what
Yeah,
did I
pretty
miss?
much. You missed a bunch of talking trash, and
Oh
about
yeah,
you should go back to dial
dial up.
up. Zoomat has an AOL disk that you can use, and you can go back to
Is it
those
AOL
you can go
4.0?
back to those chat rooms, ASL, all that good stuff,
Oh
and
yeah,
it'll be.
buddy. I don't even know, man. What happened?
Dude, how many of you guys did the AOL thing? God, that was fun.
Oh my gosh. So what happened? So let's see here. Okay.
Hold on, I need a beer. I'll be back.
All right, I guess I'm going to drone on about shocks. Hopefully my high desert internet doesn't take a crap again. So guys, is this good or is it bad? Is it boring? Let me know. You've got mail. Welcome.
What? What's up? What I miss?
We were talking about the fact that you love that movie, You've Got Mail.
You know, funny thing about that movie, You Got Mail.
Oh yeah?
I actually did go with the chick to see it in the theaters, and I fell asleep, and it wasn't a very good date, but whatever.
Every
Whatever.
day with the Chief is worse than the first one.
What?
No, what are you talking about, Dave? Huh? What? Somebody say something? Ben, I do not have a bypass here. I literally thought about that too. It's on the truck. Should
Drew says shock talk is greater than LS talk because
yeah, you
Drew
can't use
doesn't
your
have an
LS.
LS.
Okay, so this is how this works.
Tell us how it works.
So you got these little discs right here, and they bend. So oil flows up through here, and the discs literally bend up and out of the way. Now these are probably what are these 20 thousandths? I don't know.
Your internet's gonna go away again. We're gonna lose you again, but we'll see what we can do here.
So these are 30. Wow, that's crazy. It says 30. Oh, it's because it's a millimeter. Yeah, so these are 15 thou. So that's pretty much what you're going to get. On most of these shocks, you're going to have a 15-12 stack or a 12-10. So when they talk about 12, what they were referring to is a complete stack of six discs or shims or valve discs. It depends on who you talk to on the phone. They're going to call them all kinds of different names: valve discs, valve shim stack. But basically what it is it's this arrangement of metal shims, effectively. And then what also will be there is what they call a fulcrum shim, which is usually on Bilstein's side of the world is 0.5 millimeter. I don't remember what that is in thousandths of an inch or whatever, but basically this allows the rest of this entire stack to deflect a certain amount. Now, sometimes they have these things called backup shims, and they'll do is they will limit the distance this can travel to control overall flow. And when you do that, you can take a shock and make it initially pretty soft, but then you limit the total flow after a certain amount. For whatever reason, that might be something you would want to do. Say, for example, you have an issue where it blows through the travel really quickly, and your truck weighs 9,000 pounds, and no matter what shim stack you put on here, it's not enough, and it ends up making it harsh. So you would do some stuff in order to firm it up, you would have to do that, and that would also is a little bit dependent on how big around this piston is. Now, something interesting to point out is 2.5 millimeter, excuse me, 2.5-inch shocks, right? This piston is 2.3 inches. Now, everybody's paying attention here, I hope. The piston in a Bilstein is actually 2.43 inches. I think it's kind of interesting that it's 60 millimeters. 60 millimeters for the last time I checked wasn't actually 2.5. So somewhere along the lines they made an adjustment. I don't think that actually makes. Oh, Bill's out. Oh, the width. There's only, what is that, an eighth of an inch difference, something like that, or less than an eighth. I'm not good at adding this stuff up on the fly, by the way. Sorry.
Well, let me ask you a question real quick, if you don't mind.
Yeah.
On that shim pack, does the shim pack? Okay, so what orientation does that sit in the shock housing?
So what you would see when you take it apart, it would be like this. This is a spacer. It would be very basically down at the bottom. It would look like this. Now there's a bunch of extra spacers at the top just to take up space on the piston rod. So this bolts in to the top of this, and this guy sits on here and is, it's bolted in. So you don't want to have a bunch of.
So this goes up and down in the body.
Correct.
Right, but
Correct.
what I'm saying is, so do the shims? Does the piston move away from the shims when it goes down or up?
No, so this is all fixed, and that's the deflect shim, the shim deflection. So the oil flows up through the bottom, and this whole entire pack, because of its shape, it's like a pyramid. It lifts up away from the piston. So you're bolting all this down to fix it to that rod, and as you push this through the oil, it creates force based on how thick these are, how much this piston can flow, and how fast it's going through the oil. Now, this is the biggest thing here is on a coilover or a single shock, you're going to have a limit of where this is going to work. So like a smaller diameter piston, like a 2-inch, which would be obviously smaller than this, which is more like 1.8 inches, I think is what the diameter is. I actually have both sets of shims here, Tracy. So you have rebound and compression. So you can do both sides. So that's compression, that's rebound. So you have both sides of it. Would it help, Dave, if I cut this apart and put it on here?
Yeah.
You think that would help? Okay,
let
me get some dikes real quick. Hold on.
Would that help you guys? It'll help me. I have to like touch things and do stuff so I can figure out how they work. Otherwise, it gets jumbled up in my head. Those hairy old arms right there, man. Look at that. Hey, flex for us, Steve. No? Okay. Yeah, I think that would help. That would help me a lot.
Okay. So instead of having to visualize, I will give you an example. And this is good because a lot of people don't see this. So this is how this is going to go. So you have your spacer. That falls. This is actually going to go like this. So you'll have your seal head, which is going to have O-rings and stuff. And there's actually an end cap that screws to this, so it's not just that by itself. So you get the seal head, shaft spacer, your, what we are going to call your compression stack. So you have the spacer there, some shims, and then you get your small to large shim stack, right? So then it looks like this. I don't know if you guys can see that okay. But you see how that's arranged, and it's the largest shim is the last one. And then you would put the piston with the greatest amount of holes facing facing down. Is that right? Yes.
Down.
So that's the open side for the 6 holes. because that's where the flow is gonna, or the oil is gonna go this way. So you want to put it like this, lowest amount of entry holes for the rebound on the top. And then you've got your large shim. And then basically you have all the other rest of these shims in a stack here. Right? And then you have a fulcrum or a backer. We don't have a backer in this case. And then this nut here, right? Now, obviously, there's extra space, so that's where all these extra spacers come in. They don't do anything, they just take space up. You're going to see that in some of them. It depends on who it is. We have an echo, I guess. Sorry, guys. Okay. Okay, so when the shock's together and there's Loctite on this, it's going to look like that. I don't know if you guys can see that okay. So this is what controls the damping in your shock. And the reason why you have a spacer is so that this does not top out inside of the body and break all this apart. I've actually seen vehicles that don't have this on here, like hit the piston or something and bend a shim into the thing, and then it gets stuck. It's just really bad. So when this thing is going up, when it hits a bump, all of the oil that comes through the bottom here is going to bend all these kind of up. And because you have blocked off the port for the compression, it's going to create resistance. Now what you can do is there's a way you can basically bleed some of this oil off, right? So at really low velocities, and we refer to in shock tuning world speak, it's shaft velocity or shaft speed. It has nothing to do with how fast the vehicle is moving. That's very important to keep in mind. So like you hit a curb at 5 miles an hour, this thing is going to go boom really fast because you're basically moving that wheel up and down it's a 90-degree bump. Square edge bumps are really the hardest things to tune for because it's such a violent impact. Washboard. I'm going to explain that here just a second. Tracy, some of them have a rubber top-out bumper, and that would actually be here on the seal head, and it's like a ring shaped. It's not that common to see that in an off-road shock. This is the reason for limit straps. You want to strap these things about an inch before they are fully extended because the straps will stretch, and you want to protect this. You figure each one of these shocks is between $350 and $800 each. It's really expensive to replace one. You would want to do everything you can to try to keep it alive as long as possible. They require maintenance. If you're beating on your vehicles, you've got to change the oil like you change it in your engine. It's not expensive, nor is it hard to do. If you can rebuild a hydraulic cylinder for like a ram of some kind off of a tractor, you can rebuild a shock. It's not that difficult. The seal kits for most of them are around $25, and the oil is about $30 a gallon. You could do probably 6 shocks with a gallon of oil if it's a 2.5 inch. Maybe less than, maybe it's 4 shocks. 2 gallons is probably best to get because you're going to need a little bit of extra just in case, because you're going to make a mess. But basically here with this is for bleed. There's a bunch of different ways to bleed off oil for your real low velocity impacts, right? So there, you see, there's these little baby holes in here, Dave. You know, I don't know if you guys can see it okay or not, but those are usually those are threaded, and what you would do is you would put 10/32 or whatever Allen head screw in there, and that would block off flow at very low shaft speed. So going into a driveway, roller bumps are generally low shaft movement. Rock crawling would be a low shaft velocity kind of activity, if you will, because you're articulating the axle slowly. You're moving the truck, it's a very controlled and metered thing that happens. When you're bouncing through the whoops, it's still kind of a slow speed impact. It depends on how fast you're going, but it's in the middle there somewhere, right? So bleed has an extremely large impact on how the truck will ride and how it handles going around corners, when you're under braking, any of those really deliberate movements are affected by this. So one of the things that guys will do is take all 3 bleed screws out. They'll put like a 8 or 10,000 shim on the face in front of this big flat shim. So what you would do is you would take this bad boy apart, right? And instead of putting this guy in first, you would want to end up putting, for example, one of these. So you put this in, and then you got some bleed. When you put this on here now, I don't know if you can see that, but there will be some airspace around that, which what this does is it delays when what we call this is a low speed shim starts to become active. Now, if you're on the washboard or you hit a square edge bump, basically it's going to act almost the same. There's going to be a little bit of a delay or what we would call a dip in the damping curve when that happens. Now, interesting thing you can do. Ben was asking about the sizing and the flutter. So 12s and 15s, 20s, 25s, and 30s all refer to the thousandths of the thickness of the shim itself. In Bilstein speak, that's going to be like 10, 15, 25, and 30 millimeter or 0.3 millimeter. And the diameter of these makes a big difference on how and when these things are active. So if you had a 12 stack, let's use this as an example. So this is right here. This is a 15 on the low speed. And then we're going to take what we call a crossover shim. And you're doing basically the same thing, but you're going to be moving where your high or mid-speed valving comes into play. By putting a crossover shim in here, you basically space out the low-speed stuff a little bit away from the rest of this stack. And the smaller the shims get, the higher velocity required for them to become effective and to start doing damping stuff. So like washboard, really hardcore like square edge bumps, those kinds of things is when these are going to come into play. You would be really shocked at how much of an effect that these have. And if your truck is set up in such a way it's really heavy, sometimes you might need to stack multiples of these up. You might do 2 10,000 shims that are 1.3 inches in diameter. You can do double and triple flutters on some shocks. Some guys don't like doing that. That's all kind of a debate. It depends on if it works or not. But for all intents and purposes, this would be a flutter, because basically we took a crossover shim and put it in there. Normally it wouldn't be that big. It would be a lot smaller diameter. It'd be like a 1.1 inch shim instead of whatever this is. And then you would put the rest of the stack on here like that. And then I don't know if you can see it, but you would have an additional amount of space between your low speed valving and the mid speed and high speed valving. And then you would just assemble the shock the same way you did the first time, put everything back together, put the nut back on, put it in the truck with Loctite. And if you can visualize that crossover point has a huge effect on ride quality. So there are caveats that come with that, but for the most part, a guy running a truck on a trail is probably going to want to do something where the first 2 shims are like a 12 or a 10,000 shim, and the last set of shims are going to probably be between a 12 and a 15. If your truck's really heavy or you push it really hard, and what I mean by pushing it is not driving fast on the trails, is hitting bumps that are large amplitude and they are very abrupt, that would be when the top portion of this would come into effect. So keep that in mind. Just because you're hitting jumps, because technically speaking, a jump isn't actually a high-speed impact. It depends on how the truck lands. That's actually low shaft velocity because it extends all the way out, and it has all of this travel we equate to as time to come back in, and it doesn't usually happen as quickly as you would like hitting a curb. I want to look at some of these questions real quick, Dave. Let's see here. Pressure for most of these is going to be around 200, 150. Bilsteins are 250, depending on which ones you're talking about. Pressure basically is directly proportionate to how quickly it's going to cavitate based on this velocity. If the shaft velocities go up beyond what the nitrogen charge can compensate for, you are going to lose damping and it cavitates. And when I talk about cavitation, there's this thing that happens in these shocks. And Bill Stein used to have a video up where you would see like all this oil behind the backside of this piston would start to kind of foam up and turn white as it goes through the travel, which is when that when that loses damping force. That's really bad. If you can run 150 psi and you'll have less rod deflection, or what do they call gas ramp, from the pressure, because this does technically add spring rate. It's like 50 inch-pounds is what it ends up working out to at like ride height for most trucks. So if you add 150 or 200 psi, you're going to see between a quarter to half inch of a height discrepancy there. That's not, part of the springs. So that's something to keep in mind.
So basically, those shocks are better than those $20 jobbers that I got down at AutoZone for the K10.
Yeah, probably. Yeah, even these, as worked as they are, nitrogen charge seems to be the most cost involved in rebuilding shocks. Once you have a setup, it's not too bad to rebuild a shock. Okay, here's something interesting, and I'm probably going to get flamed for this.
Damn right.
Yeah. From Monroe Maddox, the yellow bodies. So, yeah, benzane's 200. That's about that average of what most people is going to run. So you do realize like air is 78% nitrogen, something like that. I can't remember. So if you use dry air from your compressor, you can run that. Yes, there's going to be a higher rise in the pressure as it gets warm. But like if you're going to go and just crawl like Drew, for example, Drew's not going to be cycling the shocks really hard all the time. He doesn't have the money to go buy a nitrogen chuck, and his air compressor goes to 150 psi, and he can actually get the shocks to 150 psi. If at the worst case, he's got to charge his shocks with the shop air and it's dry, that is the biggest thing, is the moisture in the air going into that reservoir changes the point in which it's going to basically the moisture inside the air, if it's not dry, it starts to boil, and that creates expansion and changes all kinds of things. So it won't be consistent, but it'll still work, and it absolutely should have some pressure in it if you put it on the truck. Never put it on the truck with 0 psi. It's really bad for the IFP because there's no pressure on the other side of it. And what happens is sometimes they can rock in the bore if they're worn out, the bearings on them, because there's basically one of these guys sitting inside of your reservoir, but it doesn't have a hole in it. It's solid, and it slides up and down that big reservoir that's on the outside of the shocks. Some of these have an internal floating piston above it, so the shock body's longer, and that thing floats up and down on top of this. So you'll have a chamber of oil below it, and then the nitrogen charge goes above it. Same theory is there. It's a solid piston. There's some bushing material, like a Teflon strip of some kind, and I'll show you that real quick. So when I'm talking about bearings, sometimes I'm referring to these guys. This is like I think this one's Teflon or plastic. It depends on who it is, but these are the O-rings I'm talking about that are on a Bilstein shock. They're not really very big. This is pretty much the same on a King or a Fox. Some of these are Viton. You can tell the different colors. So there's going to be a lot of, like a 250 or so temperature limit on like a Viton seal, but on normal seal, it's like 180 degrees Fahrenheit, something like that. Here is an interesting seal. So inside that seal head that I was talking about earlier is a shaft seal like this. Now, you see how that seal, Dave, has like a brown ring?
I see
this
that.
is actually 2 seals. Now, this is one of the things that's different about a Bilstein race shock and a normal shock. And this is not a Bilstein commercial. I just want you guys to know that there is a difference in the types of seals and how they work. This is a high-pressure seal assembly. So what this does is the normal seal by itself is only going to be able to handle so much pressure. And these things, when they start to move really fast, yeah, it's so funny. White Brothers. It's funny you're laughing about that, but the WP is KTM owns WP suspension. That's what that stands for. White Power. White Brothers exhaust. White Brothers suspension. There's all kinds of stuff. Custers are cool, dude. Like Custers are rad shocks, man. There's a lot of stuff in there. Juice. Don't even start with it, Jesse. It's not a Jewish company, bro. Do some research on that one. You'll find out some interesting stuff. So what this does,
Jeez, we're talking about shocks, and it's fucking getting crazy in here.
Yeah, right. So this piece here is not rubber. This thing is like a polycarbonate or something. I don't even know what it is. It's really hard to get these in and out. But this bad boy's job is to basically give support to this main seal, because this seal is the shaft seal. It's going to see all the action. It's getting worked hard because of how small it is. There's not a lot of surface area.
I bet it is.
And there's not much for it. There's not. It's got a hard life. When you have a high pressure seal, that means that the shocks should be charged higher pressure, and the pressure spikes aren't going to blow the seal out, and this thing is less likely to have an issue with leakage.
And so it's when you blow the seal out, that's when you have problems.
Dude, you don't want to have a leaky shaft.
Never.
Shaft seals are leaky. So if you noticed, one of the things to look at
Later,
here
Jesse.
is... later, bro. Viton for an off-road shock is a temperature thing. I don't actually know the reason why they went to it. I am ADS. So there's a good story. Let me talk about this real quick because I want to explain that. So 7/8, inch and a quarter, or inch and an eighth. Bump stop or an air shock is going to have this size shaft. Most 2.5 inch or 2 inch diameter shocks that have big shafts are going to have this 7/8 shaft. I mean, you can see the difference here is pretty substantial.
Substantial.
So why would you want to use a bigger diameter shaft versus one of these? Because a bump stop is getting completely hammered, and it can take more side loading than this can before it bends.
So the girthier one can take more.
Yes, but ironically,
punishment.
this is only 2 inch diameter. So you see the piston? This is for a 2.5 inch shock. So you can imagine the piston inside of here is pretty small, right? Look at the size difference. That's a pretty big difference, right?
Right.
So that's the thing, is that size does matter with the shocks. So one of the things I wanted to talk about, like that Drew brought up, you can run ATF. It's not really that great of an idea, but it works. Yeah, right. So I don't know about the Tundra world, and I don't know. There is a bend limit. There always is. So yeah, it just snaps off.
So explain to me one thing.
Yeah.
So grab your 7/8 shaft there. So we know the piston at the top, right? It goes up and down. Explain exactly what the deal up underneath it does and where
This
it
thing?
sits. Yes. No, underneath the spacer.
The seal head.
Yeah.
So this is going to be inside of the shock body. So when you look at a body of a shock, it's going to be underneath this piece here.
Okay.
So it's kind of like inside of here, there's a snap ring groove. So you're going to push that thing down, pull the snap ring out, and then you can pull everything out with it. So it's probably going to be to like here in this particular example.
Okay.
So it takes up a bunch of space. That's why big shocks are as long as they are, because there's a lot of stuff inside there, right? I mean, you see how tall that thing is. That's 2 inches. So what is going on here? Oh my gosh, yeah, C70. Yeah, Chris, that was hilarious. I had to message him about that. So that portion of the shock's job is their seal stuff on the outside here. In this case, if it's a Bilstein or any other normal shock, it's going to have one O-ring. On that one, it's got two because it's a FO gay. And then there's seals down in here, and that's that high pressure seal stuff I was talking about. Now, there's sometimes two seals. You've got a wiper. In this case, this one doesn't because it's a bump stop, but there is a end assembly that screws into that is not here. Show you real quick here. you see how that's threaded, Dave? So there's another piece that kind of screws in here at the bottom, and it's black, and it screws in the bottom of the shock, and that's a scraper. What that does is it scrapes mud and dirt and debris out of the way so that it doesn't get its way into the shock oil. And then you have an umbrella seal that is facing upwards, so when the oil is puddled around it and it's pressurized, it pushes the seal against the shaft, and then you have that O-ring assembly that I showed you that is for additional sealing, because this thing's moving up and down. You're going to want to, oil's going to want to escape, but it also needs to be lubricated. So there's a lot of kind of things going on there. And sealing is a pretty dang simple thing to do in any hydraulic scenario, especially with the way they have it done. It's pretty easy to service. You could use like 4 tools to service these shocks: a pick, a screwdriver, Allen head for the bottom cap. Some of them don't even need that. And then, a big crescent wrench, really. You could do all of that. And then it's just a matter of being patient and taking your time when you take it apart, put stuff in order, or use a zip tie. That's why I use a zip tie around that, piston and stuff, because I didn't want to, because you could literally put a zip tie through as that stuff comes off, zip tie it, stick that thing in the dunk tank or a solvent tank. You could wash it all while it's all in there. That's fine. So, anyways, I want to talk about what Drew said about us being Icon, then Bilstein, and now ADS. So when we started Fortify, we were looking for places that would help us with our shock stuff. And, I have a fair amount of experience with dirt bike shocks, and there is a lot of stuff that crosses over, but not everything. And Jake sells some of those, Drew, for like $12. It's for AN fittings. I use those on my shocks. It works great, and they're magnetic. So, and winging it, Tracy, you can absolutely do that. There is lots going on with the flow, and you are onto something good there. So on a motorcycle, you have a lot more flow, which means you got 30 shims or 20 shims versus 6 on each side. Isn't that crazy to think that on a motorcycle you have more damping stuff than you do on a truck? Does that sound crazy, Dave?
Yeah, it is kind of crazy.
30 shims, man. I mean, the shim stacks are crazy. So, and it's pretty similar size-wise. They're about 60 millimeters. So, anyways, so we're looking for somebody to help us out. And I didn't think that because of how small we were. We hadn't even sold anything at that point. We were like talking about it. And we went to Icon because I had a buddy of mine bring me a pair of Icon shocks off of his 2500 HT that had blown the reservoir off and some other crazy stuff. So I had to call these guys. I'm like, look, what happened? This might be an OEM failure because there's a roll pin. The reservoir rotates on these, and they have a roll pin that goes through them and keeps the reservoir in place vertically, and there's O-rings and stuff, and it's kind of a complex design. It works good though, but I had to go there, right? So I'm there and getting the parts, and I start to talk to this guy. I'm like, yeah, we're working on the Class 3 that Raffo has, and he's like, oh yeah, the white and red Blazer. I'm like, yeah, and coincidentally, the guy that runs operations, Jeremy, has a K5 Blazer also. So we hit it off, and I got a deal on the parts, which was really cool.
Start talking about shafts and stuff.
Oh yeah, we did.
Nice.
And basically, that actually led us into a relationship with Icon, a really brief one, but they took really good care of us. They care about their customer and the product. It's really nice. They build a shock specifically for Fortify. Like, I actually have a part number for a 14-inch coilover. You can't go to Icon and buy a standard 2.5-inch, 14-inch travel coilover from off the street. They will not sell it to you. The only time that you see anything like that is on like a Pro 4 or Pro 2 truck. Tom Way's Ultra 4? You like Jeeps? You know who Tom Ways is?
I don't know, Ultra 4, Ultra 2, Ultra nothing. I just go on I just crawl around on rocks.
Anyways, he drives I'll explain that too, Drew. He drives an orange Ultra 4 car, and it's all Icon. So one of the things that we noticed with Icon, we couldn't get stop rings for the rate stops on coilover. They have a weird 2.65 by 12 TPI, and it's like nobody would make the stop rings.
What's TPI?
Reds per inch. So I was really frustrated because I needed a part that doesn't exist, and they wouldn't make it for me, even though they made the shock. So I'm like, what the heck? I can't put a dual rate spring setup on these things. That was frustrating because that limits the amount of travel, or not travel, but the limits the tuning threshold. So I'll explain that too, Ben. So moving forward, we started to look at other companies, and um, I have a crap load of Bilstein shocks on that race truck. So we were getting ready for the mint, and I took about, I don't know, 12 shocks over to those guys, and I dropped them off. When I did that, I made a contact over there, and I started dropping some names. So I'm friends with Dave Turner. He's the one who helped me build my I-beams and everything on my truck, on Lucy. And he raced for Bilstein for like 20 years. He's a factory Ford race car driver, or was at that time, before that. And I talked to him about it, and they're like, oh, yeah, we know Dave. And then I know Chris Raffo, and he's racing for him. And I was like, hey, maybe we can get set up with Bilstein. So Bilstein at the time was doing some kind of stuff that they were trying to push their universal fit stuff. And so we're like, all right, well, we'll go with Bilstein. And there wasn't really any complaints other than the rate stop thing for the Icons. But Bilstein, we were like, man, that was like a dream of mine. I know that sounds really weird, but when I was growing up and we were doing like autocross and everything, and I was watching Le Mans and all these other racing series, like road course stuff, Bilstein was the shit. And I was like, dude, if I could get in with Bilstein, I've actually made it the big time. You know what I mean? And to be able to walk into their facility, and it takes up a half a city block per building. There's two of them next to each other. Wow. It is extremely imposing. And when you walk into their entryway, they have a friggin' NASCAR race car sitting up in the rafters that you can see. It's crazy. So I'm there, and I'm like a pretty hardcore dealer. Like, I don't think that there's much more of a discount you could get as a dealer besides what I get. Like, and I can call an engineer. I got his phone number. I mean, we got in pretty tight with those guys, and they took really good care of us, and the stuff works amazing, and it's great quality. I love Bilstein stuff. I've never had any problems with them. They've always been super awesome. They've gone out of their way to help us no matter what it was. And that's still the case today. I am still a Bilstein dealer. I would run those products in a second. I would never question it. So the problem, though, with Bilstein, and this is an unfortunate thing for them and us at the same time, is because there is a lot of red tape when you talk about a large corporation like ThyssenKrupp. And Thyssen does not align themselves with what the rest of the world thinks about off-road, because in the scheme of everything, Bilstein could literally close tomorrow and they wouldn't feel it. That's how big they are. So that mentality trickles down to budgets for marketing and development for off-road shocks, and then you end up seeing what happens where they don't have an answer to anything over a 3.5. And when you're talking about 5,000 to 7,000 pound trucks, we are basically limiting ourselves. So the reason why we went to ADS is because ADS, one, makes, I would venture to say, as good or better quality of a shock that Bilstein produces, but you go all the way up to 5 1/4 inches. They make the biggest shock in the industry. Nobody else has a 5 1/4 inch shock. Heck, I don't.
Shock.
Dude, it's 200 pounds for one bypass. Damn. You literally need two people to do it. But the thing about ADS, it's not necessarily the 5 1/4. They make a 4 inch. They make a 3 inch. The thing about ADS is these guys are just like me and you, Dave. I can sit down. We can have a beer. We can talk about shocks. We can go for a ride in a truck. We can have a good time. If I call them on the phone and I say, hey, hey guys, like, Tyler or I can't remember his dang name. Oh my God, I feel like such an asshole right now.
Don't worry, they're probably not watching.
McMaster Faber, Carl. Dang it, I can't believe I forgot that. But Carl, I'll call Carl and I'll say, hey Carl, I have this stupid idea. What do you think? And a lot about what I build is absolutely made or broken on a shock. If the shock doesn't work, my truck's gonna ride like crap. It doesn't matter how good the link geometry or any of this crap is. If the shocks don't work, it doesn't work. So, and I'm only so experienced with my, tuning. I can make a shock work pretty good, but it's not like I'm a pro. And these guys do it every day, all day long, on a world-class level. You guys saw Nelson driving that Ultra 4 car at the King of the Hammers on qualifying. He was first place. That's an ADS car. He went to Prim, and he was beating in qualifying Class 1 cars and trophy trucks in a freaking Ultra 4 car. That's crazy. So, that to me, after the fact, made it was like, damn, these guys don't mess around, and neither do we. We throw down pretty hard on our trucks, and we break them all the time. So, they're you don't realize like what things when you're in a business like this are really important. And some of it is about marketing. Some of it is about who's able to help you. I'll be honest with you. I don't really care about the marketing. I care more about how the thing works. And when I rode in their truck, they call it the Rock Rat. Dude, he was absolutely flying, Ben. I was so shocked when I saw that, because I always talk crap about Ultra 4 cars. So before Pete passed away, Pistol Pete, used to say that all rock crawlers want to be a race trophy truck driver, but no guys that drive trophy trucks want to be rock crawlers. And there's a reason for that, because driving a rock crawler is uncomfortable sometimes, but most of the time when you're driving a trophy truck, I mean, granted, it's not always perfectly comfortable. It's not the same. You get into a trophy truck. I've never been in one, but I've been in 1450 trucks that are really fast. It ruins you. You just can't go back. That's the reason why my truck is the way it is. I rode in somebody's Toyota with coilovers and Devers in the back, and we were jumping the dike, just around here. And I was just like, oh my God, I want my truck to do that. This is so fun. And I was told that could not happen. And I was like, screw you. I'll show you what's up. When I went for a ride in the Rock Rat that ADS brought out there, they were like, oh yeah, it works great, blah, blah, blah. It's on 40s, it's on tons, it's got a little Jeep 4.0. I was like, okay, whatever. How good could it possibly work? Like my Blazer has 4 tube bypasses in the front with 18 inches of travel. The back has Devers with 6 tube bypasses in the rear. It works pretty good. Like I can go sideways through the whoops at 55 miles an hour and hold it wide open when the axle's not braking. And the thing is super fun. It's not that comfortable, but it is composed when it does it. And when I rode in their truck and it was twice as smooth as mine, and it has a solid axle, and we're going probably 20 or 30 miles an hour faster. Yeah, damn it, Rob. And it was doing like 20 or 30 miles an hour faster than my Blazer, and it's running a Jeep straight 6. I'm like, I'm just going to have to shut up now.
Shut up.
Oh my God. And it was like, they know what they're doing. And I don't care who you are. If you have the ability to talk to somebody and they know exactly how to make that product work the best that it can for your vehicle, it's absolutely worth all of the money that you could possibly spend on that.
Well, it's funny though, but when you talk about rock crawling, like you're talking about like King of the Hammers style.
Yeah, I mean, that's
and bouncing it. Yeah. But like, I'm talking about different rock. If I have different kind of rock crawling, I'm like,
oh no, you're talking
crawl.
About
I crawl over rocks. Interestingly, so we had our marathon this weekend. So I got to bring Jeeps up. Anyway, sorry guys, but it was at my marathon. So 22 Jeeps. We ended up finishing after the 3 trails. We ended up finishing with 15. But the Rebel Jeep that you saw at King of the Hammers. So the guy that bought that, he was out there. He finished up at the end, and so at the end there's this badass waterfall. And that sucker's on like 42s with the LS3, just like straight built. And he just like walked it like it was nothing. Yeah, I don't know if any of you guys watched my video that is like, it's a JL thing. But he has a JL on 38s. It just totally I got him up the waterfall to where he could bump it. And he couldn't get it. It ended up damaging his rock sliders and stuff. But that Rebel rig is built. So I think it has some big ass kings on it. Like there's some monster freaking kings on that sucker.
Yeah, so that truck works pretty good. Our shop used to be next door to Rebels, the Fortify and Robert Custom Truck Shop. We literally were down the street. So check it out. When I put the clutch in Ethel the last time, I went out into the parking lot right in front of their shop, and I was just ripping donuts. So they come over the next day, and like one of the guys is talking to Jake. He's like, "Dude, we saw you guys on camera." And like after that, it ended up becoming a joke. So like every time they would come by, like our shop would be like right here, and theirs is like down, at the end of the cul-de-sac. So every time they'd come by, they'd be on the throttle. Every time we left, we'd be ripping on the throttle just to egg them on. And we also used to joke and be like, "Man, we should race Ethel versus the command vehicle, which is that Rebel." That big old Jeep that you were talking about, because we always figured, that thing probably weighs like 7,000 pounds at that LS3, and Ethel's like 4,000 with that 5.3. I don't know, man. One of these days we're going to put them head to head with the turbo, and we'll show them what's up.
Yeah, see what's up.
Oh yeah,
But
I mean, it's totally
Robert Kraft, he's down here talking trash.
What are you saying? Beat up, bounce buggies, poison spider chassis and shit. Yeah. How many boxes of Girl Scout cookies?
Hey, all I got to say about Poison Spider is their shit's fucking garbage. I wouldn't bolt up any kind of Poison Spider stuff to my stuff at all. It's garbage.
Rancho. So, anyways.
Hey, I'm talking about like sliders and stuff like that.
Oh yeah. Well, you'll put a Smitty Belt on there, right, Dave?
Smitty-built winch.
China. Anyways.
Hey, Smitty-built, Badland, all those ones, they come off the same line in China. Don't matter.
Right. So a couple of things here. Somebody asked me about Kings. I think it was Ben. So I've done a bunch of Kings. I don't know how or why. I actually hate King. Only reason I hate King is because everybody and their mother has Kings, and they all have pre-run series Kings, which really are not that great if you compare them to pretty much everybody else. Even the Foxes are better off the floor. It's just not. You're talking about a cost-saving shock, right? It's a pre-runner series. It has low-temperature seals in it. It's going to get lower quality grade oil. The shaft's lower quality. The bearings are lower quality. It all equates to you're paying money for the name. Bill Stein's 8125 was an answer to that. That's the only reason it exists. The 9100 series shocks that they had, that used to be the only thing they would sell. It was a 2.0 or 5 or 60, 46 millimeter or 60 millimeter. ADS is pretty much the same way. They only sell one line of shocks. That's it. Fox has a little bit lower. It's a factory or race series or whatever. I can't remember. Factory race, something like that. They got a special name for it to make it sound higher than it actually is. But seriously, I don't really like them. There's a couple of reasons why. That seal head that you saw in that FOA, that screw on. When you have an old King shock that hasn't been taken apart in a long time, that is damn near impossible to remove. I actually had a shock here that had a bent shaft. I cut the bottom of the shock in half. I cut it. Now, on a King, this portion is taller. It's about half of an inch. I cut through the center of it, and I still couldn't get it out of the shock because it was bound up. Part of that's the reason because of the bent shaft. But I had 5 other of those same shocks there. I had to put a pipe wrench. I used heat. I tried everything to try and break it free. Heat, cold quenching, depenetrant, everything, because I didn't want to damage the aluminum, right? Couldn't get it off, so I finally just took the dang pipe wrench on there, and I just railed on it, hammered it a couple times, and it broke it loose. But because the threads are internal, you can't get to them. On a Bilstein, there's 3 set screws that they basically are threaded into the base of that seal head. Worst case is you can get it apart. You drill them out, you take it apart, you replace the seal head, but you at least still can get the shock apart.
Yeah.
The way that the seals and stuff go in is really easy on the Kings. That part's really easy. The pistons and stuff are fine. All that stuff works good. They do last a long time. The bodies, they all look pretty much the same after a few years because the plating on the zinc plating comes off. So expect them to kind of get rusty and stuff. That's what the WD-40 or like quite literally waxing the bodies. If you live in a really bad environment with salt and stuff, there's no way around it. It's going to wear.
So you wax the shaft.
Yes, actually, yes, you do. I know you're going to joke about it, Dave, but that's actually the truth.
Nice.
Carnauba wax works really good. You want to protect them. It's an investment, right?
It's an investment. Yeah, I try to take my AutoZone shocks apart, and
you know what you use for that, Dave? The saw.
Yeah,
or
the
the band.
saw.
I don't know, Ben. You probably do. If it doesn't have a threaded end cap on the reservoir, it's a pre-run series shock or it's an older King. I don't know which ones you got, but and it's not a problem, Ben. Really, it's just about quality. It's not necessarily about the performance. There is some things about a race shock that's different than a pre-run shock, and here's my perspective on all this. When you buy and I'm going to use Bilstein as a perfect example, mainly because they're the only ones that I know of that do this out of the box. An 8125 shock has a digressive piston. Now, the way the valving is set up is not digressive. Icon, when they sell like Jeep shocks or, they have like a stage 6 kit or whatever for their coilover conversion, their pistons in those are digressive. And what that means is initial movement is restricted a little bit because you clamp down on that valving. What that does is, you can get Viton seals for everybody's shocks if you need them. So there's a recess milled into the face of the piston, and that means you can take the shims and then it pushes down into the piston a little bit, a few thousandths. It's not very much, but basically it's preloading, because effectively the way that these things work, these are just like a leaf spring. It's an upside down leaf spring that bends up and down. So you know how you put leaf springs, you stack them up. This is exactly the same principle. When you preload them, it means there's extra force, right? Well, all that body sway and stuff that, a lot of these coilover trucks have? Most of that, not most, some of that has to do with the fact that there's very little low speed damping. That's good for off-road when you want it to be all supple and squishy, but it's not good for the street because you want to turn and you need that thing to go right now. And that's that low speed control that we're talking about. So by making the piston digressive, you add force required to move the portion, the shaft of the shock at low, velocities, and that's control. So that can be done on the compression or the rebound. But like I said, out of the box, they're not set up digressively. The pistons are equal flow on compression and rebound. I don't know if you can get a digressive piston for a King or not. Now,
so basically, like when let's say you have some Fox shocks, right, and you send them out to get them tuned for your specific application. Basically, what happens is they adjust those shims in there.
Right. You're paying a guy $125 per shock to go in and do what I just talked about, moving the shims around.
Copy. See, you guys are saving money on this show, so you can donate over at Dick's Fort. No, I'm just kidding.
So that's funny you say that, though, Dave, because a shim kit, you could spend $40 and get all of the shims for these shocks. You can go on to Filthy Motorsports, Poly Performance. There's a bunch of places where you can buy CarTech. If you call CarTech and you say, hey, I want a 12 stack, so the lower the number, the thinner the discs. On a solid axle truck that's going to be bouncing around the desert and doing some rock crawling, I usually do like on the compression, I'll do a 12 and a 15. So the 15 being the mid and high speed stuff. So the 12s are going to be on the face. And then on the rebound, I'll do an 8 stack. And that would be the lightest stack, full stack that you can put in those things. And that basically makes the rebound drop out really quick. And the main reason for doing that is because you have 40-inch tires and an axle, and it needs to be back to the ground as fast as possible. A lot of weight, a lot of inertia. It doesn't respond very quickly, so you don't want to limit that rebound. You want to limit it enough to where it doesn't bounce when it hits, but you don't want to slow it down too much. That's right. The biggest thing. Rebound is one of the most effective ways of controlling the way the truck rides. Rebound and spring. The spring choice makes a difference.
Now, if you're crawling over rocks, let's say like the stuff I do, not King of the Hammers rock crawling, but you would want the rebound to be a little bit slower to control, so you wouldn't want to just unload right away. You'd want it to just kind of.
It's not going to do that, though. That's the thing. That's why you have a face shim, so it's sealed, so it doesn't just. So yes, if you have a really light valve stack, it can do that. But so here's an example. You saw Matt Kimes' truck, right? The gunk truck. That has half. Okay, well, it's one I posted. It's got blue doors. It's on 40s.
Copy.
Anyways, it's got half of an 8 stack, and that's a crawler. So it depends, and there's ways around that. One of the things is to have a higher Wait a second here. Hold on a second. Drew's saying I've seen people use JB Weld to make the pistons more digressive. I'd be interested to see how they would do that, because digressive means that it starts firmer and ends up basically going like this. A linear curve is going to start out, soft and go, pretty much straight across the chart, and then digressive piston is going to start out stiff. It's going to dip and then come back up. So there's going to be a hole in that, so it pops off the valving and will flow less initially, and then the flow will increase. Damping force is more initially, and then it's like any car you buy out of the dealership. You drive around in it and it feels a little bit stiff until you hit a big bump, and then it just like blows through it. And that's like an RV is a perfect example of that. You don't want to affect the chassis over a bump. You just want the wheels to suck it up, right? Yeah. But you don't want it to be a sloppy bitch. The reason why that isn't the case most of the time is because the valving is clamped and it's stiffer and it is digressive. So digressive doesn't necessarily, I guess, in this case, mean the piston has to be digressive. There's ways around that. You can close off flow, and they have low flow pistons. So Swayaway used to be really popular for this. They used to have this domed piston that you would buy with a short course shock, or Toyotas would come with it because of the front A-arm shocks are like 2-to-1. Low flow because the shock's in a ratio, so it's farther inboard from the tire. That means that there's more mechanical advantage. More mechanical advantage means the shock is moving at a slower speed, but it has to do more work. And work is movement and energy absorption. When you slow it down with like a 2-to-1, you increase the amount of work exponentially. So that's why the shocks heat up. Like on a trophy truck, their shocks are in the middle, the rear trailing arm. That's 2-to-1. That's a lot of heat. That's why shocks got bigger. If you would look back in the day, you would notice that they would have 2 or 3 or sometimes 4 2.5-inch body shocks, but they weren't quite as far forward, and then they weren't quite as far inboard on the A-arms and stuff, because they weren't reducing them as far. And if they were, with the cantilever of some kind, like a Baldwin used to have a crazy torsion bar cantilever with it had like 4 shocks per axle, but they were all on the chassis, and it looked really weird. It's that big old sheet metal looking thing. It's a mezzanine, so it's pretty cool. Drew's talking about I like having lots of rebound when crawling. It helps control a lot of the awkward angles you find yourself in, but anti-squat percentage is a big factor as well as the amount of rebound. Yeah, so you're talking about the fact that you can affect a chassis as far as the input from power, right? So when you accelerate or put power to something on a radius arm on the front end, or put the brakes on, you're going to move the body up and down, and that can happen with a high squat percentage on a 4-link 2. It just depends. If it's really low, it's going to want to pull the wheels. It's going to affect the chassis less with input. So when you have rebound, that's more rebound damping, then you're going to have it won't move as much, and it won't bounce and stuff like that. No, Robert, it's actually called jacking. So what happens is you have a radius arm, and you put torque into the arm, that the axle's going to want to do something. It's going to want to twist the thing in half, right? Because you articulated it and you put power into it. So either the body's going to go up or down, or it's going to articulate and it'll push the tire down instead of picking the body up. Now, we've only seen that one time in the whole time we've been building these trucks, and it was a specific scenario, and it was like an off-camber uphill, and the truck was fully articulated out, and we were going really slow. And the way we went around that was because, or the way we did it anyways, was by just driving slowly and not. Well, I'll address that, Drew, because there's something to that. Because when you move the truck, you change the point of the center of gravity around. It's not in the same place it was when you're on flat ground. So, so the reason why leaf springs are technically more stable in an off camber is because leaf springs naturally have more rebound damping than any spring, because they're rubbing against each other. So there's friction there to hold the spring in place. You've naturally added more than the shock can handle. With a coil spring, there is no friction, which means the spring is compressing, and then it's naturally just wanting to push away. Well, when you add rebound damping, it slows that extension because that's extension control, right? There's compression adjusters you can buy for these shocks. ADS makes them, King makes them, I think Fox makes them, and you can control the rebound. Some of them only do compression adjusters, but some of them do both. But that would be the way to do it, right? Is you'd valve it however you want it to be comfortable, so that the compression adjuster's in the middle, and you can go out or in to be able to compensate for that. Right? Yeah, especially if they go inverted. But so leafs are kind of funny. So here's my perspective on it. Depending on what you're doing, Grumpy, that's a really great question. A fork on a dirt bike is technically a coil. It's an internal coil shock, but it's actually almost exactly the same thought process. And so you have a spring, and then side of a fork, usually on a newer bike, it's a twin chamber, or SFF or whatever. There's a shock inside of that the spring sits on. So that outer tube is so big because of its job is to control the fork and the front wheel and the braking, and so it's just to house that. There are certain things that it does when it bottoms out. There's a spring seat that has holes in it, and there's oil in the base of that controls some of the bottoming. But the rest of it, there is a piston inside of it's like a shock within a shock. It's kind of interesting.
Yeah, what's crazy is those Oris. You've seen those suckers, haven't you?
The what?
Oris?
ORI?
Yeah, I guess. We just call them Oris, but
yeah,
but
they're nitrogen.
Yeah.
So they're kind of like an air shock too. So coilovers push because of the fact that the spring has no resistance. It's got naturally less rebound control. And there's when you link something, you basically create less bind in the whole system than a leaf spring. A leaf spring doesn't articulate as well. There's a bunch of reasons why it's going to want to unload. So no matter what type of links you use, at some point in time, whether you're vertical or not, you're going to have something that is probably not going to be optimal happen. One of the reasons why we use a long arm is when you start to get vertical or you start to go downhill, the angle of attack, right? So if you're pointed downhill and you have a short arm kit, your angle of attack's like this. The propensity for the axle to basically pull under the chassis is higher especially when you're climbing too. It happens both directions. So, it really depends on what you're going to use the truck for. It's really hard to build a perfect truck for everything. You can't. Rock crawling. You get such vertical, man.
Yeah, that question about rock crawling, I almost don't like. I think the rock crawling that we're talking about, like we're just driving over rocks. I mean, the shock helps getting you to the rocks, and like maybe if you're spinning the wheels or you're doing something, but like it almost is like a non-factor, I would think. If you're just
I don't agree, but the reason why I say that is, hey, what's up, Aaron? So shocks have a really
about time, Aaron. Buster.
Yeah, right. And Drew, yes, you're right about the long wheelbase change.
His square body probably broke down on the way home.
Yeah. So the shocks always are doing a job, right? So one of the things that's cool about a bypass shock and rock crawling is in that zone of travel, you can control that rebound or compression damping. So say a bypass shock, typically you would have a bunch more valving. Sometimes you would have a double 20 stack, right? So say you had a really crazy valve stack in there and you knew, I want my truck to ride okay, but I also want it to be gnarly rock crawling. So you would turn in your rebound tubes for the ride zone, and now you have a really stiff rebound stack so that the wheels don't drop out really very fast at all. It's all about the slow speed control, and it's in a specific ride zone. So it's only in 4 inches or 6 inches of travel in the middle, but at the ends of it's got a different damping feel. That's because it's position sensitive, and that's the reason why Drew, that's a great example. Broomstick on the floor and hit the expansion joints. You will learn really fast about attack angle and how it affects the way the truck drives, climbing or later gravity, climbing or coming down a hill. So basically what I'm getting at is the shocks have a huge role. When you ride in a truck that has a properly tuned suspension, you'll never want to go back. It is always more comfortable and more controlled. And the main thing here for everything, if you build link suspension for your trucks in any way, when you start to get the shock tuning and you get it right, when weird stuff happens, you're able to control the truck and you keep it from crashing more easily. So that's part of the reason why, like when you see me jump in my truck and stuff, you very rarely will you see it bounce when it lands, or when I'm going around a corner or something like that, because you have such a wide range of leeway, of, if you will, when you're hauling ass, or even if you're going slow, you just get a better amount of control out of the vehicle because you are able to control the aspects of the suspension and what the tires and wheels are doing more precisely. And that basically ends up, paying back when you spend the money on that stuff. It absolutely is worth it, even if it's just rock crawling, even if you're just using a coilover. It's worth the money. It's a safety thing. It definitely helps. It's a comfort thing. That's a nice byproduct, and it's also a capability thing because you can adjust stuff, spring rates, bottoming control, all kinds of stuff.
I think I learned a lot from this episode.
I hope everybody did. And
Yeah,
Drew's here
pretty
talking
awesome.
about bypasses are awesome for higher anti-squat systems. They can control the tires wanting to brake traction and hop around. Yeah, so when we're talking about the front suspension and it being a radius arm, when you apply power to the front, it actually wants to pull the axle up because it has a high number anti-squat, right? When you hit the brakes, it's planing the tires down. In the rear, very rarely do we ever go over 60% because we find that a little bit of the squat is going to help drive the chassis into the obstacle. Too much is going to want to lift the rear suspension up, and it just causes things bad to happen. It's easier to control wheel spin than it is to control wheel hop. Yeah, right, Ben. We're trying, dude. Yeah, I'm glad, Bob. Hey, I'm super happy that you guys are doing.
It's awesome. I was talking with Steve about this. We were talking about actually doing this episode,
nice.
And we're talking about, like, can these guys go deep? Because a lot of guys lose focus. So it's like, I think you guys are like because I think it's cool to learn about this stuff, especially from somebody that does it every day. So it's pretty
Thanks,
awesome.
man.
You guys stuck with us and
yeah, man,
and kind of went through the whole thing. So all I know about shocks is I buy the cheapest ones I can find, but I'll probably do something different.
I'm glad you guys are interested in this stuff. I have a lot of opinions on it and whatnot. And if you guys want to talk more about it, I'd love to talk more about it. I'm not a pro. I don't tune every day. I have a lot of experience just because I try things. I'm not afraid of it. People sometimes will tell me, "Oh, you can't do that," and I really thrive on being able to prove. Yeah, we should do a geometry episode. That'd be really cool. Drew, you should bring yours over, and we can put it up and lift it up with the hoist and show people stuff. That'd be really fun. I'm not sure if you're down, dude. Bring it over, dude. That'd be super cool. I'll clean the garage out, and we can just extend the thing and show people what's up. Because I feel like there's a lot of Wiccan voodoo effectively out there that people are like, oh my God, I can't do it. It's crazy. And it's not like that. You guys are all good with motors and transmissions and axles and stuff like that. These things have literally, it's got one moving part, Dave. This part stays still and this part goes up and down. That's it. That's all it does. It goes inside some fluid. It goes.
Nice. Open wide.
That's terrible. Chris is probably going to get all excited. So, anyways,
he's not even in here. He probably fell asleep.
Like that's a perfect example. I don't want to pick on Chris. Yeah, I do. So Chris broke his truck on the first jump, but he learned how to go into his shocks because he had to, right? And I don't know if that was the first time he had ever rebuilt them or not. And hey, and you know what, Rob, the 5100s, it's a great shock, and it's probably fine for most people. These are, just a bigger range of control. It's like fuel injection, right? You got mechanical fuel injection, and you've got electronic fuel injection. The main difference between the two is mechanical has so much compensation built into it. It's a few percent total, and then you look at electronic fuel injection. You got 30%. 30% is a huge band of control. I mean, you could do all kinds of stuff with that. You can kind of screw up a shock, and even if you put the wrong valving in it, say for example, you accidentally put a 20 stack here on the rebound, and then you put a 10 stack on the compression. Well, it just means that the shock's going to extend really slow and it's going to ride like crap. It isn't going to break the truck. If you really screw the assembly part of this up, yes, you will break the shock. Pay attention, take pictures, don't be an idiot. Write it down. That's what I do is I take them all off, and then I lay them out, and I put them in order, and then I measure each shim, and I analyze it. I look at it, and I go, okay, my truck, when I'm going through the whoop-de-doos, the rear end kicks up. Now, there's two reasons that I generally would assume that would be happening. I'm running out of travel and bottoming it out, or the rebound is three reasons. Rebound is too slow, and it's packing up, which means that this is stored energy. So this thing is going up and down, and the rebound's too slow. So what happens is it starts to basically stack up, and the shaft doesn't extend back all the way out in time for the next bump. And when it finally extends, it hits the bump in a weird place and kicks the truck up in the air, or the compression damping is too stiff, which means it's transmitting the energy into the chassis. Those are the three basic reasons why a truck would like kick.
Later, Ron.
Later, bud. So,
let's just say,
yeah.
let's say somebody, a rock crawler, or somebody's going to drive through the desert, and they want to get, let's say, the best, maybe not the best, but the most economical shock that they can rebuild and tune. What would you suggest?
So, as much as I don't like them, they are the cheapest, is those FO gays. They work okay. I definitely would not recommend them unless you absolutely have to. The more economical thing to do is probably buy a used set of older shocks, like some Custers or some Kings or some Foxes or Bilsteins or whatever, ADS, Icon, something. You can buy a used set for between $300 to $800, right? Now it's about the same price as a new one. A new shock, $520 for basically, or $550 for basically anybody's 2.5 each. That's no springs. It's expensive. That's remote reservoir. It doesn't matter what travel we're talking about. That's a coilover, dual rate coilover. You need a bottom and a top spring. Everybody's shocks are basically the same price for the most part. If you're buying a used one though, you might be able to pick up a King 2.5 inch or 2 inch for $500 with the springs. Maybe the springs are what you need. Maybe they're not. That's part of the thing, right? You can get them on YouTube, yeah. So it depends. So if you go and rebuild a shock, and the shafts need to be in good shape. Pitting on the shafts will eat the bearings and the seals very quickly. So that's easy to tell. You just wipe them off and look at them. If they're all sand pitted, don't buy them because shafts are $80 to $100, and then you're in seals. Well, there's another $25. So now you're $100 to $150 on top of what you paid for them. Does that make sense? No, it doesn't. I got a lot of guys that want to rebuild them. I'm like, dude, I wouldn't even waste the money. So you can see how this could kind of spiral out of control, right? It's like everything else. I bought this LS for $100. Oh, and it needs this. Oh, and it needs that. Oh, and it needs that. Go buy the $500 LS, and you won't be spending as much money total.
Yeah.
You look at a pair of shocks, and it has new shafts. So, hypothetical. Say you bought a pair of Kings from a guy, and the shocks on the XL outside, they don't look that great, but they have good shafts, and they're scratched up, and maybe the bearings need to be replaced. You get them home, and ironically, you pull them apart, and you find out that there's ATF in it. But the internal of the shock is really clean. The bore is nice. It's just you look at it the same way you look at a cylinder bore on an engine. It's because you got a wear band and a piston and everything goes up inside there. It's got blow by, and there's those same kind of problems. When you pull a shock apart that's been maintained, even if it's the wrong oil, chances are you're probably going to be able to use it. If you buy a shock that's got a wasted shaft, and you find out the thing ran low on oil because the seals were leaking, now you have problems with all the rest of the bearings and stuff inside of those. Now you're potentially going way deep, and then you're possibly into bodies of shocks being replaced, stuff like that. That gets out of hand really fast, and it gets extremely expensive, not worth the time or the money. So That's it. It's a matter of being smart about when you buy them. You can kind of tell, and when you compress a shock, you should be able to, if it's off the truck and it doesn't have springs, you should be able to push it down, and you should be able to hear when it extends. It should extend all of the way, whether it has nitrogen or air in it. You can bike pump the thing to 50 psi. So bring a friggin' compressor, pump it up to 50. You should be able to compress the shock all the way, and it should extend all of the way out by itself, and you should hear it go. You'll hear like a little clunk at the bottom of the travel, and what that is it's that shaft bearing. Because what's going to happen is the air pressure is going to force this thing out, and you're going to hear you hear that's what's clicking. It's a stop. That tells you there is enough oil in that shock for it to completely extend. A hydraulic ram that is not bled properly will short stroke, and it won't completely extend under pressure because there's air in the system, and the air is compressible. So there's something going on in there. That should be a red flag initially. It's not a deal breaker. It just may mean that it's low on oil, which means all of this shit inside could potentially be worn out because it got starved of oil at some point. Anything that gets starved of oil generally gets wrecked, right? That's kind of a good rule of thumb. You don't want to starve shit of oil. Doesn't matter if it's a shock or an engine. So I agree with this too. So what Drew's talking about, there is you can take like a sharpening stone from a knife, or even if I've had to do sometimes where the burrs are really tall. You want to just take the nicks down to basically a divot, if you will. You want to smooth it out as good as you can. These shafts are really, really hard. I don't know if this one has any nicks on it or not. This one's in pretty good shape. Yeah. So I'm not afraid to take a really high grit file or something to a shock shaft that's had a rock hit. Doesn't bother me a single bit. You figure these things are hard chromed. They're pretty beefy, and so you can take a couple different grades of like a 800, 1,000, and 2,000 grit sandpaper, and basically work that nick out of the shaft. And probably what will happen is it'll leak once it gets to that point. Now, the part that you need to worry about is where the shock is at ride height. If there's any really big nicks there, it's going to leak more, and it might wipe the seals out. It's not going to last forever, but it's not going to mess the function of it up that much because tiny little nick isn't going to be a deal breaker because you have two sets of seals in the seal head to keep it sealed up. So if it sits there and leaks a little bit when it's parked, it's not that big of a deal. Right. It's like the SR71. Yeah, viscosities are. So here's the thing. So there's two things that people say all the time that it bugs me, and I don't agree with, is using nitrogen pressure and oil viscosity as tuning methods. I don't disagree with each one independently, but they're band-aids. And here's the reason why. When you buy a shock from King, they sell you two different grades of oil. You get a pre-run series oil or a race series oil. The difference between the two is temperature and flash point. So like a normal oil may have a 200 or 300 and some change degree flash point, and the race oil has like 400 degrees, right? And they can get that hot. We're never going to get them that hot. ATF and stuff like that, the way it's rated in the viscosity index is not always what it says on the bottle. So that's a big deal. What you look for in an oil is stability, temperature stability. When the oil gets to operating temperature, its viscosity range where you're going to use it should be pretty much the same, which means if you start out with a 10 weight or a 5 weight or whatever it ends up being, AW32 is a hydraulic oil. I want to say, I think that's like a 10 weight viscosity in. You can look it up on the internet. I don't know what the chart says off the top of my head. I'll get to air shocks in a second. So the oil viscosity, you need to pick the oil viscosity for the conditions you're going to use it in. It's just like a motor oil. If you're going to be in the wintertime and you're never going to get the shocks over 80 degrees, probably should pick a light oil. If you're going to be out in the desert, 10 weight's probably okay. 5 weight's okay. Just know the oil is going to break down probably quicker, and it won't be as stable at high temperatures as it would be if it was a higher viscosity. Pick the oil for the application and the conditions. A rock crawler, for example, might benefit from a higher viscosity oil because you want to add some compression or rebound dampening, right? Well, what you can do is use the oil to help that. But remember, you also are hurting your compression damping, and you have to compensate for that. What that number actually is and the percentage of how much it throws it one way or the other, I don't know. I run AW32 in my shocks when I'm tuning because it's so damn cheap. I can get 5 gallons of it for like $60 at Napa. So to me, I'm not running it hot when I'm doing the valving checks. And even if I do, it's still stable. It's a hydraulic oil. That's all these things are, is hydraulics. I don't know of a hydraulic oil that is straight weight. The thing you need to look at is there is a temperature range, and I'll put a chart up on Instagram, and it'll talk about viscosity ratings, or maybe I'll put it on CK5. But there is some science to that. So one of the things you can look for is there's usually an MSDS or some data sheets that you can get from an oil brand. The thing that I realized was like AW20 used to be a base that a lot of these shock oil companies would run in the olden days in the 80s and the 90s, and then they would add stuff, polymers and things like that to help with stability or longevity or oxidation or things like things like that. Friction, right? Because you want to kind of get away with the least amount of static friction as possible. The oil has a lot to do with that. So a good oil is going to last longer and not break down.
I would think even just a like a 30 weight oil, like once the temperature reaches a certain amount, like that, it's still going to break down and
right.
get less viscosity.
Right. So, and they usually will say in a certain rate that weight rating is 30 weight at 120 degrees or something, for example, or 200. So that's where that rating comes from. Is it's like you have this scale that goes, as in an arc when they pick like the middle of that range. And my thing is okay, my truck is going to most of the time probably will be around 150 degrees of temperature in the shocks, and you can buy an IR temp gun and find out for yourself and test this. And yes, you can use a transmission oil in your shocks. It's not going to hurt them. It's not optimal. If you're screwing around, it's not going to hurt anything.
Zumat's taken off. He can't.
Later, bud.
Can't hack it.
And I'll close this up here pretty quick, Dave. So anyways, yeah, there is. Yeah. You can even JB weld them and use 1,000 grit if you had. Actually, I've seen that done with super glue too. So here's the thing: air shocks is an emulsion shock. This is basically an air shock. It's really no difference because the reason why an air shock works is this is why the truck moves up and down when you add pressure to it, because the diameter of the shock shaft is directly proportionate to how much pressure is in here. So there's a calculation that you can do for a pressure vessel or whatever you want to call it, pressure chamber, and I don't remember what it is. But it's X, what the diameter of the shaft is multiplied by the number of PSI that's in here, which will displace the shaft a certain amount as far as a spring PSI number, whatever you want to call it. So it'd be like 150 inch pounds or 80 inch pounds, and they'll tell you in the manual it can handle up to 800 pounds per corner. Well, the front of your truck weighs 1,600 pounds. Well, you need 800 pounds a corner, right? For example. But that doesn't mean it's got to be at 800 pounds when it's sitting at ride height. It might only need to have 250 pounds at ride height to hold it up. So, but the total capacity of the shock should be within the weight on each corner of your truck. And most Chevys are going to be around 850 to 1,100 per corner in the front, and somewhere in the range of that in the back, 600, 6 to 1,000. I mean, unless it's like a crew cab, or a Suburban with big heavy stuff, and you can gain weight pretty easily, but that's been my experience. So the air shocks are cool for cruising, and the ride height adjustability is really cool. We're actually working on remember that Johnson lever? No, KX. I mean the air SFF air shocks and air forks are They work. So we're working on. Do you remember that Johnson lever I told you guys about? There's going to be possibly some hydropneumatics that go along with it. And the thing about that is we're going to separate the air and then the oil like you would in a traditional shock, and still use that as effectively an air shock, because we want the right height adjustability. We want to have the ability to add and remove weight and not have it affect the ride quality. I mean, dude, can you imagine being able to like roll up to an obstacle and hit a button and then lift the back of the truck up a little bit so it doesn't roll over backwards?
Yeah.
Or control it per side and still jump it? I think all these things are great because that's the part that gets you closer to that all around truck, right? Is
instead of having a winch in the front and a winch in the back and sucking up your axle. Yeah.
You just hit lower or raise on a switch on the dash. It's like hydraulics, but it actually moves up and down like a normal shock, a shock would. So we're working on trying to figure out that system and using it with like an external bypass paired with it, so that you have some zone control. Some zone damping control. So there's a lot of science that goes into it, but that's the thing. You really have a range when you pick this stuff that the truck's going to work within. It's hard to hit all of them.
Yeah.
The Honda-matic. Hey, and so did the what's it called? It's a Citroen. Used to have hydropneumatics for shocks. It has an accumulator, and when a thing would lean one direction, it would basically move the oil to the opposite side of the vehicle so that it wouldn't sway. That thing had no sway bars. The Citroen C4, I think. I can't remember. If Chris is still in here, he'll probably know what I'm talking about. It's a really funny looking car. Just look it up, Citroen and pneumatics, hydropneumatics. Yep. It's pretty neat.
I guess on that note, guys, we should probably wrap it up because we're going on 2 hours here. But yeah, I thought that was an awesome show. I really learned a lot, and it was cool these guys joined us. So hey guys, so check it out. So we're always kind of trying to come up with things to talk about on the show, and obviously, Steve has his strengths and I have mine, and like this was a cool episode. I didn't do much talking because I was doing a lot of listening and trying to learn about shocks here. But if you guys have ideas of stuff that you want to see on the show, put it down in the comments of the video, not like in the chat here, and then I'll look back at it and we'll see if we can come up with a good topic for next week, and that'd be cool. So
sounds good. And thanks, guys, and appreciate you joining us for so long, and look forward to next week.
All right, you guys, take it easy. See you next week.